Hello, welcome to the object-oriented programming activity, I say, sounding vaguely like a robot or something along those lines. Like all activities, what I'm going to do is I'm going to load up the activity description and I'm going to go through it step by step. I think the dream scenario is that you kind of pause at each step as well and try and work out what to do, and then you can kind of see what I do and you can compare notes with that. I will try not to make mistakes. Oh, goodness. I will try not to make mistakes, but I probably will make mistakes, and hopefully that will somehow be educational as well. We'll just see how it goes. So this is just me trying to do the activity, and hopefully it goes okay. Don't know why I'm being so negative, but here we go. Let's try it out. So let's go over to the browser here. This is the activity description. And as it says up here, the sort of the point of the activity is continuing to get comfortable with object-oriented programming. Most of all, that means defining classes and thinking about this idea of how classes interact with one another, or how we can write the code that does that. And then, just for fun, this activity includes the idea of acceleration and gravity for a kind of pleasing movement effect, and because it's good to at least try these things. So we'll try them out. So the context of that is this idea, which is going to be a juggling simulation. So we're going to have a little paddle at the bottom of the screen, a little rectangle. We'll be able to move it around with the mouse, just left to right. And then from the top of the screen, some balls will fall down according to gravity. We're going to have gravity involved. And if they hit the pedal, they're going to bounce up and fall again and bounce and fall. But if they miss the pedal, they're going to disappear off the bottom of the canvas. And that's it. We're going to try and keep it simple. It's still a decent amount of work to do. You're probably by now familiar with the idea that even fairly simple ideas like this actually require a relatively significant amount of work. That's just programming for you. A lot of the time, there's a lot of sort of basic stuff that has to be built up so that you can do the interesting bits and pieces that you want to get done. So let's plunge in. First step, create a new project. Classic step. This is super familiar to you by now, so I'm not going to just go through it step by step. Well, I am, because I have to do all of them. I have to download the template, I have to open the template, and then over here on my old computer, I'm going to drag that template. This is the folder that I just unzipped. I'm going to throw that into my activities folder of cart253, my repository. I'm going to rename it. I'm breaking with tradition. I'm not going to call it '06 blah, blah, blah. I'm just going to call it Juggling Simulation. Doesn't really matter what number it had. So it's just called Juggling Simulation, and now I've got my template. And oh, right, and of course in GitHub Desktop over here. Interesting. This is because behind the scenes I did an extra little thing in there. So it's currently just thinking that there's nothing changed. That's fine. If there had been some changes, I would, of course, have committed them, but I guess I don't need to. You commit them if you see changes, you probably will. All right, we're ready. We're ready to work on this. Oh, well, I guess, it's probably important that I open the juggling simulation in Atom. I can do this on a Mac by just dragging it onto the Atom folder, application icon, or I can in Atom do the old open. I don't know why I'm explaining to this. You already know all of these things. Nonetheless, I'm going to open it this way. Activities, juggling simulation, POW. Good. So here is my program. Just because I want you to be able to see more, I'm going to delete these comments. Obviously, I shouldn't do this if this is a proper project, because comments are super important. But I just want to keep things kind of clean visually so you can focus on the code that I'm writing and that you're writing. Okie doke. So to make this simulation, there's a few different bits and pieces. Most obviously, there's the paddle and the ball, and then there's paddle talks to ball. So I'm going to take it in stages. First of all, I'm going to define a paddle class. I could define the main program first, but there's nothing much to do in the main program until the paddle exists, at least. So I'm going to define the paddle class, which will involve making a new file and adding it to the index.html. And then I'm going to write a constructor and methods that will move and display the paddle so that the paddle can do stuff. And then in order for that actually to be reflected in my program, I'm going to set up the main program, create canvas, set a background, and then I'll add a paddle to the program so that we can see it do its thing. Once I've done that, I'll do this more complicated step of defining a ball class. So I'll, again, create a new file for the class and include it in index.html. This one's going to require a few different methods. In fact, it also is going to require a gravity method, which I haven't mentioned here, but we'll come to that. And it needs to do a bunch of things. We'll talk about it when we get there. And the ball, just to start off with, so we don't have to worry about the paddle ball thing initially, it'll bounce off the bottom of the screen. Often you do things like this just so you can get stuff working a little faster, and then you modify later to get the perfect version. Just like with the paddle, I'll need to add some balls to the main program in order to actually see that reflected in any way. And I'll do that in an array because I want more than one. And we'll use the standard approach to using arrays to do that. And then finally, the last kind of step is to make the ball, any ball, bounce on the paddle, because that's the whole point, and also actually make the ball kind of fall past the paddle should it go past the bottom of the screen. I also didn't mention that here. I'm a terrible person. If I feel like the flow is going well and I can do it, it would be nice if when the balls bounce off the paddles, they could kind of bounce a little bit sideways as well. Like maybe if it's towards the left edge of the paddle, it bounces more to the left, just because that would be visually a little bit more appealing, and it would actually make it a more entertaining simulation. We'll see how we go with that. So let's begin. First step, define the paddle class. It's the easier of the two, so let's start with something easy. And let's just follow these steps here. First of all, we need to create the class file. That involves creating a new file with the same name as the class, which is paddle.js, and making sure that we include it in our index.html. Anytime we add a new JavaScript file to our project, we need to make sure we include it in index.html. So I want to create my paddle.js file here in the JS folder. Perhaps the easiest way to do that is to right-click or context-click on the JS folder itself, and I can select New File. That makes sure it starts off in the JS folder. It's just, I mean, I could type that in as well, of course. And I'm going to write paddle.js. The convention is that always classes are named with a capital letter, and the file is named after the class. So this should be paddle.js. Now it exists. I'm going to be a tiny bit cheeky because I feel weird about just having a blank file, and I'm going to quickly write in the basic class template. That's actually the next step, but I'm going to do it now. To write the basic template for our class, we know that we write class. That's the special word that tells JavaScript we are creating a class. Name of the class, which is paddle, capital P, because it's conventional to name your class with a capital letter. And then the block of code following that will be where I'm going to define it. So blah, 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 but not that. That's where we're going to define our paddle class. And in fact, if I'm doing this and I'm just me, given that I know that the class definitely has to have a constructor method, I would also add that in. So that's constructor, spelled like that, parentheses because it's a method, which is really just a kind of a function, and the constructor's block of code inside curly brackets. And this is where I'll set up paddle stuff, but we'll come to that. So returning to the actual steps, because I went a little off script there, off script, ha ha ha. Oh boy. I also, whenever I create a JavaScript file, after doing some kind of minimal amount of work, I really shouldn't do too much at all, but I think it's a good idea to at least have the really basic structure of a class there in place. I need to make sure I go to index.html, and I need to make sure I write a script tag. So this is the script tag that includes my main program. If this wasn't there, then my main program wouldn't run because my web page, which reads index.html, wouldn't know about the script. I need to do the same thing for paddle, so I'm just going to duplicate that. And I'm going to say, also, you should include this file, paddle.js. That's also part of the program. I put it before the script because the script needs to know about it. So I want paddle to load before script, ideally. Okay, that's why they're in that order. That is important. Okay, so we've done that. We've done our duty there. The paddle is now part of my overall program. It's included in index.html, but the paddle doesn't do anything. So that's going to be what we probably want to do next. Okay, so we've done create the class file. We've actually done this step too. Like I said, it kind of felt more natural to me to throw in that basic structure already. And I've already done a little bit of this next step too, because again, it feels like the natural way to initialize a class. So we want to add our constructor, and this is where we start thinking about the nature of the paddle. In particular, when we create the constructor, we're thinking about what properties will this thing have. So what properties will a paddle have? It's going to need a position, so an X and a Y, because it's got to be somewhere. And it's going to have a width and a height because it's a rectangle, and I want to know its dimensions. It should know its own dimensions, right? Goodness me. And just because it seems sort of nice, the width and the height are going to be passed in as parameters. The position is not, because it's gonna move with the mouse anyway, and I'm gonna want to lock it to the bottom of the canvas because that's where it should stay. So there's no real point in passing in those parameters. So first of all, define a constructor method with two parameters, W and H. I'm avoiding calling those two parameters width and height because I don't want them to conflict with P5's variables called width and height, because I'm actually going to use the height one. So what I have here, this constructor here, I'm going to need to, and I'm assuming you can pause. I'm just going to kind of keep going, but I'm assuming you can pause when you want to do a step. I'm going to want my two parameters there in the parentheses, right? So now when I create a pedal, I can give it a width and a height. Now I'm going to create my properties. I'm going to start by creating the width and height properties since the parameters are right there, and I'm going to set them to W and H. So to create properties, I need to remember that I need to write this because this refers to the paddle that is being constructed, the paddle that's being created. So I always refer to this. This just magically comes into existence as part of the constructor. It's as if it declares a variable called this, right? That you can then use from then on in the class. You don't do it yourself. So you don't write let, for example, here. I'm defining a property called width. Here I can use the word width because it's part of the paddle, this.width. So it doesn't conflict with the P5's version of width. And I'm going to set it to whatever is in the W parameter. So if I passed in 100 into the W parameter, this.width would be set to 100. Same thing for the height. So that sets up those two. Then I also want an X. I'm defaulting it to 0. I suggest that just because it's going to move with the mouse anyway. It doesn't really matter what it starts at. And the Y needs to default to be at the bottom of the canvas. And I've got the maths for that here, which is that we're going to set it to the height of the canvas minus half the height of the paddle. The reason for minus half the height of the paddle is to offset it away from the bottom of the canvas. And I'm going to use rect mode center later on in display, and so half the height is what's going to do that. So this.x is going to start as 0. I could also start it as undefined, I suppose. That would be fine. I'm just going to start it as 0. That seems maybe ever so slightly safer. And this.y is going to be the height of the canvas, so it's going to be right at the bottom, minus the height of the paddle divided by 2, so that we offset it away from the bottom of the canvas. Okay, that's my constructor. It just sets 4 properties. It's not a big, complicated one. It's doing what a constructor should do. Movement. Okay, for the paddle to move, it's very simple. It's only going to move according to the mouse position and only horizontally. So we only need to use X. So we're going to define a move method in this, the usual way. And in the method, all we have to do is set the X property to be the same as the mouse's X position. So that's pretty straightforward. So define a move method by writing move with parentheses and then a code block in curly brackets. And then we want to set this.x, which is the x property of this paddle that I'm trying to move in this instance because I'm inside the move method. So this.x is the paddle that's moving, and I'm going to assign it mouse x, which is P5's magical variable that tells you where the mouse is. That is visible within this class. All of the P5 variables and functions are visible inside this class, which is handy. So that's movement done. Wow, simple. Finally, display. We need to be able to see the paddle, probably. So we're going to need a method that displays the paddle, and that's just going to draw a rectangle at the position of the paddle, and we'll choose a fill and a stroke to do that. But basically, it's called draw a rectangle. So it's called display. I don't need to call it display paddle, right? Because that would be silly because we already know it's a paddle because it's in the paddle class. So it's nice that I can just call it display. I should always push and pop around drawing instructions. And then what do I need to do? I need to set a fill. I'm just going to be boring and make it white. I'm going to set no stroke because I don't want one. And then I think that's all. Oh, and rect mode center, right? That was important. I said I wanted to use rect mode center. To me, that just makes some of the maths a little later on feel slightly easier. It's not, you can do it in other ways. I just prefer it this way. Rect mode center, and then I have to draw a rectangle. Gosh. And remember, again, because I want to use this paddle that's being displayed, because we're in the display method right now, I say this.x, this.y, this.width, this.height. Those are the properties that this paddle has, this paddle. Okay, and that is it. And that's actually it for my paddle. That's all that I need. It's a nice short class definition, I think. Yeah. Okay, so we've got a paddle, but main script doesn't do anything, therefore my program doesn't do anything. So even though I do have this great definition of a paddle, a definition on its own, a class definition on its own, doesn't do anything. You have to make a paddle out of this class definition to get results in your actual program. So I believe we're going to move on to that, right? Set up the main program. Indeed, indeed. Ooh. So let's do the most basic stuff, which is create a canvas and set a background, just because we almost always want to do that. So create canvas. I'm going to go with window width and window height today. I feel like that is going to be nice. And draw, I'm going to go with the old black background. You can choose whatever you want. Done. Now the excitement begins, because I can now add a paddle to my program. This is one of the things I like about object-oriented programming, is like the paddle is just this kind of entity that is defined in another file, and to use it I just need to do 3 basic steps, which is I need a variable with the paddle that's going to store the paddle. In setup, I'm going to create the paddle and put it into that variable using new paddle, and in draw I'm going to call the paddle's methods. Those are the big 3. So first of all, a variable, paddle. Second of all, in setup, paddle is assigned what? Well, we want to assign a new paddle, like that. And remember, I said in the class definition of paddle, it takes two arguments because it has 2 parameters. And the arguments are going to define the width first and the height. So I'm going to make it 300 by, big decisions, 20. Let's see what that looks like. It's going to be kind of skinny and wide. Okay, good enough for me. And finally, we need in draw, because this is where we're drawing the paddle and making it move and stuff, we're going to have to say paddle.move, which is its first method that moves it to where the mouse location is. I don't know why that has decided to indent a little bit. And paddle.display, which is the thing that makes the paddle appear on the screen. Paddle.move, paddle.display. Now we have a program that creates a paddle and uses the paddle's methods to make it come alive like Frankenstein. A very white and rectangular Frankenstein with no dead body parts of any kind. I'm going to get off that tangent. So that is it. That's it. That's my class definition of paddle is done, and I've included the paddle in my main script. What do the instructions say? Now we should have a program vaguely worth looking at. Yeah, so we should be able to move the paddle now. We all know as programmers that's not necessarily what's going to happen when I run this program. But nonetheless, let's start a server and see what we get. Oh, what do you know? There it is, it's working. So the paddle, you can see at the bottom there, 20 pixels by 300, sorry, 300 by 20 pixels. And you can see my mouse as I wave it around. You can see that moving the mouse up and down does not move the paddle up and down because we only work with its X. And the paddle follows the X position of the mouse with its center. So this is a nice way for me to move this paddle around on the screen. Wonderful. I can actually make it jump, right, by kind of tricking it, going off the canvas, sneaking around, boop, and doing that. That's exciting. I'm sure you're really interested in that. Okay, so the paddle's done. So let's move on to the kind of the main event to some extent, which is this ball class, which is going to be much more sophisticated. So we want to make a ball. We're going to need, as always, a class definition, and then we're going to need properties, and we're going to need methods. Now this ball is going to do a little bit, like a lot more really than the paddle. In particular, it's going to move with velocity and acceleration, which is going to look really cool. And we're going to have a special little thing, which is it's going to use gravity. So that's going to accelerate it downwards. And the ball is going to bounce off the bottom of the canvas for the time being. So there's quite a few things to do. So let's get cracking, as they say. So the first step is the same as the paddle. We have to create a new file with a class definition in it and save it into the JS folder and make sure we add it to index.html. So I'm going to go and do that. What's another way to make a new file, you ask? Well, if you just go to File, the File menu, and you go to New File, or I can hit Command-N. I'm going to do that. It's probably Control-N on Windows. Command-N. It makes a new file. It's called Untitled. And it doesn't ask me where to save it yet because I haven't saved it. So I can do it this way, and I can say class ball, which is going to be a class definition, and I can write the constructor like that, just as the sort of the basic little default. You might notice, I hope, that this is all white text. Now it hasn't highlighted in the way that we're used to. The reason for that, you can maybe guess, is that Atom, does not know what kind of file this is right now. I can't tell that this is JavaScript. I could be, writing a poem or something as far as it's concerned, and maybe this is a nice poem. It's not until you give a file an extension that Atom knows what kind of file it is, or it assumes that it's that kind of file. So until I save this file with a .js extension, it can't really do its special tricks. However, now I can save my file. That would be Command S, as we can see here from the File menu. I always prefer to use keyboard shortcuts. Command S, Control S on Windows. And now it asks me where I want to save it. And now I want to specify the JS folder. And I'm going to save it as ball.js. Okay, ball.js. Save. Okay, and that worked. And you can see now that it's got that JS extension, it's all highlighted and stuff. Of the two methods that we've looked at today, I kind of prefer the right-click new file. It immediately saves the file into the correct folder, which I think is good, and it saves the file right away. So you as soon as you begin, you get this nice color highlighting. That's up to you, though. As always, now we need to go to index.html and make sure to include our ball script. I'm going to duplicate this line that included the paddle, and I'm just going to change paddle to ball. So this now includes that ball.js file. It doesn't really matter what order ball and paddle are in, unlike with the script. So, it's your choice. This, however, does say PBS, which is a very worthy television channel in the United States, the Public Broadcasting Service. Does not really matter. Gosh, very tangenty today. Sorry. All right, so we're ready to start defining our ball class. Let's go get our instructions again. So add the class structure. I already did that. As you've noticed, I prefer to kind of do that as soon as I create the new file. Add a constructor. Well, I've done a little bit of this, but there's a lot more to do. So when you create the constructor, you need to be thinking, well, what does this thing need to know about? What are its properties going to be, right? The most important thing, I guess, about the ball is that it's going to move. So it is going to need a position, it's going to need a velocity, and it's going to need an acceleration. And it's going to have a maximum speed. We're going to have a maximum speed because it accelerates. We don't want its velocity to become arbitrarily large, right? We don't want it to sort of just start moving at the speed of light or something over time. We want to cap its speed, especially for something that's falling. You don't want it to accelerate indefinitely because there's a point of what is called terminal velocity where something cannot accelerate anymore just from falling. And that is the behavior that we want. So a maximum speed, that's going to be the terminal velocity, really. We're going to pass the position as a parameter, two parameters, x and y. That just seems polite. It's like good to be able to specify where the ball is going to start off. And, and just for later on, because this is often useful with any kind of thing that you're making in a simulation, I'm going to have an active property, and that's going to determine whether or not the ball is still kind of a part of the simulation. Do we need to keep paying attention to it? It's going to start out as true, of course. Okay, so define a constructor method with two parameters, x and y. So my constructor does not have parameters yet, so I throw in x and y there. Add properties for x and y and assign them the values in the parameters. Maybe I'll do this one step by step. Maybe then I won't miss anything. So two properties, x and y. As always, we write this.x to make that property exist, and we assign it the value in the parameter x. Same thing for y. In the method, add properties for x and y. Oh, Jesus, I just did that. I'm gonna. Step 3, add properties for velocity and acceleration defaulting to 0. So it's going to start not moving. So we know that for velocity, we need a Vx, that can be 0, and a Vy, that can also be 0. Now we're going to have acceleration. I usually call these Ax. That can also start as 0, and Ay. It's also going to start as 0. So we've got 4 properties relating directly to movement. A maximum speed property, set it to something like 10. Okay. This is that terminal velocity idea. Max speed is going to start as 10. That is so that a ball, when it's moving, can never go any faster than 10, which means 10 pixels per frame. Add a size property and set it to 50 is my suggestion. Let's be renegades and set it to 40. God, this might change everything. I may have discovered something. No, that's not true. And add an active property that defaults to true. Okay, this.active is assigned true. That's the properties of my ball. It's more sophisticated than a paddle. As you can see, it has more properties, so it can kind of do more stuff. Back we go. So now we're going to need different methods from the paddle. In particular, we're going to have this gravity method. So one of the big things that's going to happen to the ball is it's going to be affected by gravity, and that's going to allow it to fall downwards. So let's do that. We're going to define a gravity method, and it's going to take one parameter, which is a force. You may need to take this on faith if you're not already familiar with how gravity works. Well, I mean, we're all familiar with how gravity works, but if you're not familiar with the math. So one parameter called force. This is going to be used for applying gravity to the ball. Add the force parameter to the ball's y acceleration. So this is how gravity works. We have the ball's y acceleration, which is this.ay, and we're going to add the force. So we don't know what the force is when we're inside the ball because gravity can be all kinds of different things in this program. We're going to define gravity in the main script later. But let's imagine that the force is like 0.5 or something. So at the beginning of the program, the acceleration is 0. And then as gravity gets applied, the acceleration is going to increase. Okay, it's going to get accelerated more and more. And that's going to cause the ball to move downwards if we provide a force that's a positive number. We'll see this in action. Okay, that's done. That's what gravity does. Now we want movement. Now the movement is going to be the standard kind of movement in that we want to add the velocity to the position, right? But before we do that, we actually want to add the acceleration to the velocity. So I've got to define a move method. Let's do that after the constructor. Doesn't really need to be after the constructor. I think I'm going to put it after gravity. That makes more sense. First there's gravity, then there's movement. That kind of makes more sense to me. So move. Add the acceleration to the velocity for x and y. So this is just like the standard math of acceleration. This.vx equals this.vx plus this.ax, and this.vy equals this.vy plus this.ay. That's how you accelerate something. You add the acceleration to the velocity. It's just one extra step of math, really. Now, we have to do the terminal velocity thing because the acceleration is going to make the velocity get bigger, and we don't want it to get way too big so that the ball is moving much too fast. So we want to constrain the velocity based on its maximum speed, the max speed property, this one here. So to constrain things, we say this.vx, this is the thing we're going to constrain, is assigned to constrain whatever is in this.vx now, constrain it to be between negative this.max speed and positive this.max speed. Pow. Yeah, same thing for vy. I'm just going to copy and paste this. There's not much point in me writing it out again. Multiple cursors are your friend. There we go. So we've constrained Vx and Vy to make sure that they don't get beyond the terminal velocity. And finally, the final step is the standard step that we're kind of maybe a little bit more familiar with, which is we add the velocity to the position. That's the other step. Without this step, the ball wouldn't move because the position wouldn't change. So that's the little magical formula. That is not a magical formula, it's just mathematics, it's just physics. So the big difference here is, one, we're using acceleration, so we add the acceleration to the velocity. That's all that's the big thing that you do to have acceleration in your simulation. We constrain it because we want a terminal velocity, so we don't want acceleration to make the velocity go arbitrarily large. And then we add whatever the resulting velocity is to our position to make the thing actually move. And that's it. That's true of any acceleration that we're going to do in any program. Okay, we're getting there. The big other trick, maybe apart from this acceleration stuff in gravity, is the ball needs to bounce. So what does that look like? Well, we are going to need to check if the ball has reached or passed the bottom of the canvas. That's the height of the canvas, right? And if it does, we need to send it back upwards. The main thing to do that is to reverse its y velocity. So how do we do that? First of all, we define a bounce method. So what the hell? Let's do it. Define a bounce method in the usual way. Write an if statement that checks if the bottom of the ball has gone past the bottom of the canvas. Okay, so we're going to need an if statement. If, and what are we going to say is in this condition? I want to check if the bottom of the ball, how do we specify the bottom of the ball? So this dot y is the center of the ball vertically. So if I want to get the bottom, I'm going to have to add half the size of the ball onto that, because that will shift to talking about the bottom edge or whatever of the ball. Now, if I'm wanting to say that it's gone past the bottom, I'm going to have to check if it's greater than the height of the canvas. So if the bottom of the ball has gone past the height, this is the situation where I want it to bounce upwards. It may also be nice to do greater than or equals to, I think, because we also probably want to bounce if it is precisely touching the bottom of the canvas. So this dot y plus this dot size over 2 is greater than or equal to height. If that happens, I want to bounce. So if it has, this is inside my if statement, reverse the y velocity. So how do I reverse the y velocity? This dot vy is what I want to change. How do you make it go to its opposite? You want to make it the negative of itself. So if it was positive, i.e. it was traveling downwards, then to bounce, you want to make it negative so that it travels upwards. The other thing I want to do is I want to set y acceleration back to 0. This is technically a little bit funny, but it will make a sort of more entertaining simulation. So it will no longer be accelerating down. This means that it can just bounce perfectly forever. So this dot ay, which is the acceleration, is set to nothing. So the acceleration of gravity, the force of gravity is going to have to build up again on the ball in order to pull it back down. And that will lead to a kind of a nice cheerful bounce. So that's it, that's bouncing. Check if the ball, if the bottom of the ball is touching or is past the bottom of the canvas, i.e. it was traveling down and it reached the bottom. If so, reverse its y velocity so it starts going up and set its acceleration on y to 0 so it can bounce nice and high. Okay. Final step, a familiar one. Let's display the ball. I don't think any of us really need to read this. We know that we need to fill and stroke and draw an ellipse. The great excitement of drawing circles. So display, push and pop, always a good idea whenever we're drawing something, and then off we go. So fill, I'm going to make it kind of reddy pink. And I'm going to have a stroke. I'm going to have a stroke just in case the balls are overlapping. I want to kind of be able to see that. I'll make the stroke. Gosh, I'm thinking about this way too much already. I'll just make it black. That's fine. And I need to draw my ellipse at the position of the ball, which we know is this dot x. That's the property x of this ball that we're drawing. This dot y, this dot size, and that is the ball. It's a fairly short class, but it's doing some sophisticated things, I think, particularly these three methods here, right? The gravity force is something we haven't seen before. That's about changing the acceleration every frame by a small amount so that it accelerates downwards. The move function is a little bit extra because we've got the idea of acceleration added on to just the basic idea of velocity. And the bounce idea has this idea that we reverse velocity when we touch something. And that's what bouncing is in physics. Okay, done. Once again, of course, this is not going to do anything until we actually add some instances, unless we create some ball objects and use them in the main program. So let's move to that idea. Now, because our balls use gravity, we're going to want a variable that tells us what gravity is in the program. So in the main script, I want a variable called gravity force. Or I could call it gravity. I'm not 100% sure that it has to be called gravity force. I mean, it doesn't have to be, but I'll call it that. And it's got a very small value. We can play with this later, but generally speaking, we don't want a gravity force to be very high because we don't want it to accelerate things downwards super fast. We want them to fall a little bit gradually. But again, this is something we can play with. So let's do that first. In the script over here at the top, maybe it's at the very top, gravity is very important. Let gravity force is 0. What did I say? 0.0025. I'll stick with that. So that's the gravity force variable. Now, so now we're going to do something that's hopefully familiar, which is we know that we're going to have an array of these balls. So we're going to need a variable that is going to contain an empty array at the beginning, and we're going to need a variable that tells us how many to create. So declare a variable called balls and assign it an empty array. So that's where we're going to keep them. So let's do that maybe after the paddle. Let balls, that creates the variable called balls, and we're going to assign it an empty array, square brackets, empty square brackets. Step 2, declare a variable called numBalls and assign it the number of balls you want in the program. This is how long the array is going to be at the beginning of our program, how many we're going to create. I'm suggesting 3 because it's such a classic juggling number. So to do that, let numBalls is assigned 3. Now we're ready to go. That kind of setup for populating an array at the beginning of the program, it's very consistent. So first step in setup, gosh, what do we want to do? We want to write a for loop, of course. It's going to count from 0 up to numBalls. That is always what we end up doing when we're adding things into an array. So in setup, after we make the paddle perhaps, we are going to write a for loop. Writing a for loop that counts from 0 up to numBalls. Let's do that. For let I is the classic name of the variable, starts off at 0, keeps going while it is less than whatever number is in numBalls, and goes up by 1 every time. That's I++. And inside its block of code, this is going to be repeated 3 times because that's what numBalls is. In the loop, create a new ball object and assign it to a variable called ball. Give it a random x argument on the canvas, so anywhere horizontally, and a random y argument that is above the canvas, a negative y. That's because I want my balls to start above the canvas and kind of fall in. And I'll make it random so that they don't all fall kind of in lockstep with one another, side by side. So, okay, let's do this step now. So I want to create a new variable temporarily, let ball. This is just for inside this loop. And I'm going to assign it a new ball, because that's how we create new objects. This is the name of the class that will, in fact, call the constructor. And I want to provide it with an x and a y. They're sufficiently not complicated, but what I'm actually going to do is I'm going to create variables for these first. So the x can be anywhere on the canvas between 0 and the width. That's random 0 width. And the y is a bit different. It's going to be a random number, but I'm going to start, I don't know, -400 to -100, let's say. So they're going to fall, the balls are going to appear somewhere between -400 and -100, which is always above the canvas, and they're going to fall down. Then I can use those variables as the arguments for my new ball object. That's just a little bit tidier. You don't have to do it that way. You could put those 2 randoms in here. I just find this a little bit more readable to look at. Okay, and next step, push that variable, the ball in that variable, into the array. Okay, so we've created it. Now we say balls.push ball, and we're done. Okay, final step in order for these balls in the array to do anything is we're going to have to call their methods. So once again, we have to write a for loop and call the methods inside that for loop. Same thing that we did for the paddle. So same kind of for loop, it's going to count, but instead of up to numBalls, it counts up to the length of the array now that we know that the array has a length. So let's write that first. So maybe we'll do this after the paddle. Yeah, we'll do it this way. So for let I, again, is assigned 0, I is less than balls.length. Again, this is important that we use balls.length here because if the number of balls changes in the simulation, maybe at some point we'll add the idea that you can add balls or something like that. We want to make sure we're always still counting the actual number of balls in the array. I++. So that's my for loop. That's the classic go through an array for loop. In the loop, call the ball methods on each ball object. So gravity, move, bounce, and display. Okay, so I'm just going to call them. So first of all, I'm going to pull out the ball just because I find this more readable. So I'm going to pull out the ball at the current index that I'm counting from. So this will be 0, then 1, then 2 as the loop executes. So this will be the 1 at position 0, then 1, then position 2. I just find this more readable because then I can just say ball.gravity. Now gravity requires an argument, which is the amount of gravity, and I made a variable for that called gravity force. Then after gravity, I'm going to say ball.move. Then I'm going to say ball.bounce, and then I'm going to say ball.display. Those are the things that a ball likes to do, or at least those are the things it knows how to do. May or may not like it. Let's try not to think about the objects in your programs being miserable about the things you're making them do. That would be very sad. Okay. Oh, they did that. So all going to plan. Again, very important that this is hypothetical until we run the program. We should now be able to move the paddle, which we could do before, and we should have 3 balls drop from the top of the screen and bounce off the bottom. Let's see if that is indeed the case. Oh, there they are. That is satisfying. And just looking at that, like I hope that it's apparent how satisfying this acceleration version of things is, right? So this is the force of gravity that over time accelerates them downwards each time they bounce up. And it's just a very nice form of movement to look at, I think. Clearly, there's one more thing left to do, right? Which is that currently these things don't care about the paddle. They just are bouncing on the bottom of the canvas, and I want them to bounce only on the paddle. So that's really our next step. But this is still already quite beautiful to look at, I think. It actually is making me want there to be more of them. So I'm going to go and change numballs to 10, just because I think that would be satisfying. Oh yeah, look at them go. You can already probably think of things that you might like maybe different speeds that they fall at, different sizes. But for now, let's just continue on. So that's done. Final step, make the balls bounce on the paddle, not on the bottom of the canvas. So this is this classic idea where we end up wanting to have 2 different kinds of objects from 2 different classes interact with one another. And how do you do that? So we are going to use the idea that it's going to be in the bounce method that we're going to handle this kind of new special bouncing, which takes account of the paddle. And that's because the ball is the thing that bounces. So it feels like it should be kind of in charge of this particular event of bouncing. It already has a bounce method, so this seems like the right place to take care of a new kind of bouncing. There are arguments to be made in all kinds of different ways. So this is not the only solution, but I think it's sensible. Now, there's a paddle that we need to deal with, and so the bounce method is going to need to be told about the paddle, and the way we will do that is by passing it as a parameter. And then we're going to need to just calculate the bounce a bit differently. So let's add a parameter called paddle to the bounce method. And obviously we're editing the ball.js now. So here's bounce. I'm going to add a parameter called paddle so that it can pay attention to the paddle. Now, this gets a little bit complicated. This is some collision detection code that we need to write because we need to detect, essentially, is the ball overlapping the paddle? That's the question that we have. And then how we ask that question in programming is clearly with a conditional, because that's what we always use. But which conditions we use to check is something that is mathsy. So I'm just going to do it. If I'm going to explain it, but allow yourself some time to let this sink in if it seems like it feels a bit unnatural. So there's 2 basic things that we're going to have to check. One, and that's basically the 2 axes, right? The first thing is that for the ball to bounce off the paddle, it needs to be somewhere within the horizontal width of the paddle, right? So the X position of the ball has to be greater than the left edge of the paddle, and it has to be less than the right edge of the paddle. Otherwise, it shouldn't bounce. So let's do that first. Let's write that if. So I'm going to just leave this other if down here because we are actually going to want this code here for bouncing. Maybe what I'll do is I'll delete the old conditional and I'm going to write bounce above this stuff here to remind myself of what it does. I mean, obviously, I know. And I will grab this in a second and I'll put it into the conditional that I'm going to write now. So how do I check if the left edge of, if the ball is past the left edge of the paddle? I'm going to say, is the ball's X position, which is the center of the ball, greater than the position of the left edge of the paddle? So is the ball, which is this, because we are the ball right now, talking about bouncing, if the X position is greater than, because we want it past the left edge. So how do we talk about the left edge? Well, we need the paddle's X position, but that is in the center of the paddle because we're using rect mode center. So to get back to the left edge, I need to subtract half of the paddle's width. Okay, that's how we check the left edge. That's the idea of the left edge of the paddle. It's center X position minus half of its width gets us to the left. So if the ball's X is greater than that, it's somewhere past that left edge, but that's not enough. We also need to make sure that the ball is less than, not past the right edge. So that would be this dot X again, but we want it not to be past the right edge, so it has to be less than it. And again, we have to have paddle X, that's the center, and we add half the paddle's width to get to the right edge. So that's the beginnings of this. That's the first part for checking X. I'm going to add my my curly brackets there now as well. They're tabbing a little bit weird because I did this to make my conditional a bit more readable. So we know that inside this conditional, I'm going to want to bounce. So I'm going to put that code in there now. There we go. That is also indented a little bit funny. I'll do that just manually. So this is half of the equation, but I still need to make sure that not only is the ball within the width of the paddle horizontally, but that vertically it is overlapping as well with the paddle. So is it? Well, we need another and. How do we check this? Well, we know that it's overlapping vertically if the bottom of the ball is past the top of the paddle. That's half of how you check if it's overlapping. So how do we do that? This dot y gives us the center of the ball. So to get the bottom of the ball, we have to add half the size. So that gets us to the bottom of the ball. And if it's going to be past the top of the paddle, it would have to be greater than the top of the paddle, which would be paddle.y. That's the center of the paddle. So the top of the paddle, we're going to subtract paddle.height over 2. This is maths, right? This is some maths around geometry. So that will tell me that if the bottom edge is bottom edge of the ball is past the top of the paddle, and the corollary basically is if the top edge of the ball, this dot y minus this dot size over 2, that's the top, if that is less than the bottom edge of the paddle, paddle.y plus paddle.height over 2. You can see the symmetry here, right? So those are all of the 4 conditions that we need to check. And if all of those are true, that's why I'm using and, these double ampersands. If all of them are true, then the ball is overlapping with the paddle. And we know that it should bounce. And we know that bouncing is just this piece of code that we already had. Okay. That one took more effort, right? But it was worth it because it's very exciting. So we've done that. We've done this as well. There's this advanced idea. I'm going to move past it for now and see how I feel about the amount of time that I'm taking up right now. So moving on. Now, this is something you can figure out for yourself. It might be a fun little challenge. It's to do with the velocity, changing the x velocity based on how far from the center of the paddle the ball is when it bounces, just as a little hint there. There's a couple more things to do. We're almost there. But I also, to go along with bouncing off the paddle, I also want to take, now what this means, let's go and look at it. Okay, let's go look at the program. Calm down, calm down. There is an important thing that we need to do that I have forgotten to include here. God, that's pathetic. I'm so sorry. You may hopefully have been screaming at your screen or noticing or feeling uncomfortable. I said that bounce now needs to have a parameter, which is the paddle. And I did that, and I took account of it in the bounce code. But in the script, when the ball bounces, which is here, I don't tell it about the paddle, so this would never work. Okay, so I do have to make sure that it gets the argument of the actual paddle in my simulation, or it wouldn't bounce off the paddle. But now let's see if that basic bouncing stuff works. Go back over here, wait for some balls to fall. There we go. So you saw the ones that weren't intersecting with the paddle just fell off the screen, and they continue to fall into the center of the earth. There we go. But the ones that are overlapping the paddle bounce off of it, and we can let them gradually miss each one. Oops. So that worked, right? That bouncing works perfectly. It's bouncing off the paddle. It's not perfect though, because all of those balls that have now fallen off the screen, they're still being simulated. It's still trying to display them, it's still moving them, it's still applying gravity, and it's still doing the other thing that I can't remember. Oh, checking whether it's bouncing on the paddle. That's really pointless because there's nothing for them to do anymore. I don't really want to simulate them falling into the molten core of the Earth. And so the final couple of steps here is in the move, and arguably you could make this another method, but I'll do it in move. We want to check if a ball has gone off the bottom of the canvas. We should set active to false, and then we should only deal with balls in the main program that are active. So let's do this. Check if the ball has gone off the bottom of the canvas and deactivate it if it has. So in move for the ball, which is here, after we've done everything, check if the ball has fallen off the bottom of the canvas. So if, now we're clearly dealing with the Y, right? That's the thing that handles the vertical position. But if we want to be fancy, we should really check, is the top of the ball off the bottom of the canvas? So that would be this dot Y minus this dot size over 2. That's the top of the ball. And if that's greater than the height, that's greater than the bottom of the canvas, that means that this ball has gone all the way off the bottom of the canvas, and we should set this dot active to false, to deactivate it. Now, just setting this dot active to false like this on its own, that doesn't do anything, right? Unless I use this, the value in here, whether it's true or false, to do something somewhere, this is just like, it's a piece of information that doesn't have an effect. So we also need, if we head back over here, to only do stuff with balls that are active. And so we should use it, and in particular, therefore, in the for loop where we call all of the methods of these balls, we should only call the methods of a ball if it is active. So we're going to need one more conditional, right, in the main script. And that will be down here. So after I've grabbed this one out of the array, I need to check, is it active before I go ahead and call its for methods. So I'm going to say if the ball.active is true, if ball.active, only then should I do these methods here. And I'll just do the tabbing. I'm realizing I haven't set up my auto indenting very well for these examples, which is pathetic of me. So if it's active, then gravity, move, bounce, display. As soon as it falls off the bottom, the code that we just added to move will set active to false, and then none of this stuff will happen, right? Because the ball.active will be false, and we don't need to worry about updating it. So it's a really nice trick. It makes the program more efficient, for example. Good. That won't change the visuals of the actual working program anymore, because it just looks the same. It's just that now you can rest safe in the knowledge that all of those balls that fall off the screen are not active, and they're not being simulated, and they're not being displayed, etc. So your program is working better. And that is it. I'm feeling like I kind of want to add in that last little bit that I talked about. Let me just scroll back up to it. I said it's maybe a bit advanced. It's actually just one line of code, but just conceptually, maybe it's not the easiest, or maybe 2 lines. So I want to move the ball a bit horizontally based on how close it hits the edge of the paddle. I want to add a bit to its velocity. So let's see if I can work out how to do this, as I have kind of forgotten. So we're going to do this in bounce, right? So it's only when it bounces. So that's the bounce code that we have. That's for changing the Y. Let's also change the X based on bouncing. So the first thing I need to know is how far away from the center of the paddle was the ball when it bounced. So we're going to calculate that, and I'm going to call it dx. That's kind of a mathy physicsy thing. That means the difference in the x-axis, and that will be this dot x minus paddle dot x. That's how far away it was from the center when it bounced, right? Because we're inside the if statement. So this is only being calculated if we did bounce. Now I can do something with this information. I'm going to set this dot vx, because I know I want to change the horizontal velocity. And I'm going to set it to what? I said that I wanted to add something to it. So I'm going to say this dot vx equals this dot vx plus what? And And this is where I need to think about it. So what I really want is I want to add more velocity to the ball in the x, the closer it was to the edge. So the closer it is to the left edge, the more negative velocity I want to add so that it bounces left. And the closer it is to the right edge, the more positive velocity I want to add because it was close to the right. Okay. Now, I'm just thinking about the kind of value in dx here. So this dot x minus paddle dot x. So if the ball is on the left-hand side, that's going to be negative because paddle dot x is going to be greater than this dot x. So it's negative if it's closer to the left, and it's positive if it's closer to the right. So what we're going to want is a map. And we're going to map dx, which is going to be a negative or a positive number. Now, what is the range is dx in? Well, the furthest left that it can bounce is going to be half the width of the paddle away from the center. So that would be, when we subtract them, that would be negative paddle dot width over 2. That's the furthest left it would be able to go. And the furthest right is the same except positive. So that's the range that dx is going to be within when I do that little calculation. What I want to set it to, I don't really know. I want to map it, so I know that if it was on the left, it should go left. So I want a negative number. I'll say -2 and +2. I don't really know. This is the number that I put here is going to affect how much impact bouncing off the edge is going to have. But this is it. This is the thing. And congratulations to you if this makes sense. I don't think I did the most amazing job of necessarily explaining it. But basically, the closer it is to the left edge, which would be this one here, the closer it's going to be to -2. It's going to have the greatest leftward velocity. Closer it is to the right edge, which is when dx is closest to paddle dot width over 2, the right edge, the closer the resulting addition to the velocity is going to be to +2. And it's going to have the greatest rightward push. Let's try it and take a look. Here they come. Dum, dum. Oh, yeah, I'm into it. That is pretty good. You can see it really changes the nature of this because I can, oh gosh, darn it. You can see that you can kind of encourage them to head towards roughly similar, there we go, that's pretty good, trajectories, but you can see it gets out of control too. It's clearly made this whole thing a lot more interesting than it was before. Oopsie. One thing it does, of course, is it allows the ball to kind of get lost off the right-hand side, or left-hand side in that case, which is kind of fun as well. But you could imagine some changes you might want to make based on that. Okay, so I did that. I should really wrap this up. I'm sorry. I'm keeping you up. So we're done. It does what we said it would do, and it's cool. I think that's a cool simulation of bouncing things off of a paddle. It feels like juggling a little bit, but you can imagine lots of other stuff you could do. Bouncing the balls off the left and right would be a good idea, very similar to the code that we saw already for bouncing off the bottom, except dealing with the x-axis. If they moved at different speeds, maybe they had different maximum speeds, or they were different sizes, or they bounced differently, like as if they were made of different materials, that would be kind of cool. A second pedal would be really interesting, so you could have two-handed juggling. Sound would be obviously good. Adding balls to the simulation could be good as well. There's lots of stuff that would be really cool. Don't forget to commit and push. I guess I will do it. I know that I never do. I'm sorry. Finished OOP activity. Terrible. Okay. That's it. Sorry, yeah, got distracted there. That is the object-oriented programming activity. It didn't go as poorly as I expected. I shouldn't have been so negative. I hope that was interesting. I think it leads to really interesting potential projects down the line as well. Hope you feel the same way, and I will see you in another video at another time, except that I can't see you.